Welcome to the channel where all you gotta do is buy more stuff for my crowded shop. In this case, a fuel injection or fuel injector tester. It says heavy, but it really isn't. I don't know where this is made. Oh, that probably explains it. So I was gonna just make one of these. I got a bunch of Motec M4s laying around that I could use to, you know, click, 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 change speed, click, 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 whatever. Really all you need is a fuel pump and fuel pressure regulator and fuel rail and some graduated cylinders. And by the time you have that all together and the power supply and yada yada yada, it's like this thing's really just like for what you get, really quite inexpensive. So it's unlikely that I'm going to use it as is because the fuel, like the size injectors I'm going to be needing for the V10 and for the Bronco are going to greatly exceed how much capacity this thing has, but it's a start and it doesn't take up much room. I can throw it up on the mezzanine, super light, even though it says heavy. It's really not, 20 pounds or something with all the box. So anyway, we'll get this thing unboxed. Probably the first thing I'll flow on it because my assessment of the S85 that I pulled out of my Copart car was that a number 10 cylinder hydraulic, and I was thinking that was because of, you know, coolant, but it totally could be in an injector sticking. So those injectors are still in those fuel rails sitting over there. Yeah, anyway, over there somewhere. So I'll number those 1 through 10, and this is a 6 injector version, so I'll be able to run 5 of them with, you know, a known injector, and then the other 5 and compare the 5 with that known injector. So that's why I got the 6-cylinder one, because if you do a 4-cylinder one, then yeah, how do you fix that, right? So you have to run like 3 and 3 and 3 and 1. That doesn't work very good. So I guess it works for a V8, but it was a little bit more expensive, like another $60 or something. I think this was like $280. And the 4-cylinder version was $230, something like that. So it's very cheap. And it has a little ultrasonic cleaner, so by the time you take it into consideration, okay, it's got an ultrasonic cleaner, which I don't have, and it'd be nice for, you know, cleaning out carburetor parts and stuff for my quad bikes, and, you know, compactors and trenchers and whatever else I got around this hole. But so anyway, that's another, you know, $50 or something for that I would have spent on a ultrasonic cleaner. So now I have that as well. So anyway, let's get this thing open. You're tired of listening to me yammer on about useless things. Oh, look how cute the little funnel is. Looks like about 1,000 little adapters for different length injectors and stuff. We won't be needing that. Alright. Well, there it is. All its glory. Huh. I figured this would be plastic, but stainless steel. Kind of feels cheesy, but whatever. This seems to be my fuel level. It's just got a little vent on there and a clear tube, so it's fine. Yeah. Our cables, a little hook on there. It's got a nice little ferry holder thing, so you can. They're not really the center of mass, but maybe when I put fluid in it, they will be. Alright. Like M3 screws. Which we put over there. Promptly throw in the garbage can, probably. Alright, let's see what we got going on here. There's some interesting MacGyver stuff going on. This feels like an afterthought. It's like a, not RTV, but it's kind of a little bit harder than RTV kind of stuff. I guess those were vibrating off. This looks like your standard Chinese power supply here. And that looks like the control board. It's got some switching transistors and stuff in there probably. And then I'm not sure why that looks like a mirror, but that looks like a mirror. It's like a polished stainless steel laser welded tank. Very, yeah, it's got more of that goop on there to keep stuff from vibrating off. That tank doesn't look very big. I may be mistaken, but it looks about 4 inches square, cubic, whatever. But it's very shiny. I don't know why they would use a shiny tank, but the welding looks nice. This looks nice. Got a ground wire going to the ultrasonic tank. Nice. And this must be the bzzz machine here. So all in all, this doesn't look terrible, except for this. Probably the ultrasonic cleaner just vibrates everything apart. So that was their solution. I mean, if it works, it's a good solution, right? So, okay, so I imagine I'm going to probably have to make a bigger tank at some point and put a bigger pump in it and a mechanical regulator. This one, I believe, has like a pulse width modulated pump driver in here, because you can change the pressure with these little buttons. So it's just changing the duty cycle of the supply voltage, DC voltage. So that's fine. Like some cars do that as well, but if the PID loop isn't set up for the actual pump you're using, it won't work. It'll hunt all over the place. So I'm expecting that to not work. And just using a, you know, lithium-ion battery or whatever, to, because pumps take 30 amps and the power supply probably doesn't have that much. So to run big, you know, 1000 cc injectors on here, it's going to need more probably. So anyway, it doesn't look terrible. I mean, it looks pretty good, honestly. Now we just have to find some fluid. Like in my past life, I actually had a fuel flow bench, what I call a fuel flow bench. It's kind of like a homemade cylinder head flow bench for air, and it was for testing fuel pressure regulators and stuff. So for supercharged cars, well, I have a patent on it. It's expired now, but I'll put it up in the corner up here. But it's basically, it's a stock mechanical, you know, fuel injector that keeps the pressure across the injector constant, 3 bars or 3.5 bars, whatever the regulator is designed for. And then as soon as you get under boost, it adds some percentage, right? It might be like 2 psi per pound of boost or 5 psi per pound of boost, whatever. So I had a flow bench to characterize, you know, those different designs because we had a patent on it. So we sold fuel pressure regulators to, you know, other people that made supercharger kits. That's a more appropriate fasteners to put this back together with. Empty out the bag of giblets. If you don't know what giblets are, whoever cooks your turkey, ask them. They'll know. This looks like an adapter to a Strange. This is like your 15mm adapter that's that long. And this is an adapter for an itty bitty one again. That's the same as that. So 2 lengths for a small diameter. And yeah, a short one, and then this is just to cap it off. So these just go in here in case you're flowing 4 injectors on a 6-cylinder machine. You can just block that off. So yeah, that's not awesome. So it looks like the connectors don't have an actual EV1 or EV6. You just like stick them on there. So I guess it'll work. And these things just interface with this. This looks like it actually will interface with an EV1 injector. So this is like an adapter that goes into there, and then you can put this on a different kind, I guess. So, and then this is just like a, that goes in there, so you can tighten it down. So, and a cute little funnel. What I'm going to start out with until I get my fancy fluid, which I'm not sure what I'm going to get yet, but I think I found some on eBay for like $80 a gallon, which, sure, this is $10 a gallon, but it smells funny. But I'd rather put some cheap fluid in there in case there's any debris or whatever. Like, all this stuff is, you know, just machined and assembled, and there's going to be burrs on things and whatever. So I'd rather put some cheap fluid in there just to flush everything, flush the pump, flush the tank, flush all the lines, and then we'll drain that out, put the $80 a gallon stuff in. So I tried to use this funnel, a cute little funnel, and I was just holding it like that with my hand and it cracked. So, cute little useless funnel. Okay, I got all my injectors out. I put a little bit of marker on there. Well, I put some yellow on and then Sharpie on so you can see it. Black Sharpie doesn't really work very good on black. So I got 1, 2, 3, 4, 5, and 6 in there. Got it full of Stoddard solvent. Well, no, I got it full of odorless mineral spirits, which I can assure you is not true. The odorless part, definitely not true. Should be called stinky. Oh, this cord is 2 inches too short. I'm gonna have to put that in the review. Never mind, I fixed it. Alright, let's see if we can't get this framed more appropriately. Alright. There's probably an on button somewhere around here. Power switch. Woo! It's beeping at me. I should probably read the instructions or something, but whatever. Okay. So I'm a little bit over the max line after everything's settled. That's fine. So this looks like functions menu, so I can scroll up and down on that. '24, that must be when it was built. Interesting. So that's ultrasonic cleaning, idling test, 0 to 20 milliseconds. That seems reasonable. So if I push start, it ought to like start clicking them, right? This one looks very much more atomized than the rest of them. This one looks like crap. Not sure if it's the light or light kind of makes it hard to. This one looks. I don't know. Could be the light, but they're definitely sparkling. That was a long 10 minutes, but hopefully you guys didn't have to wait as long as I did. So this is what we got. There's some bubbles in there, which isn't great. But this guy here, all these are really far off. Like this one here is like 74. This is like 72. This is like 82. 72. 75. 75. So this is terrible. Like you want all those to be within, I don't know, a couple percent, not 10%. So for a 507 horsepower normally aspirated V10, that's pretty terrible. Although it could be that 5 of these are clogged up and one of them isn't. Although that's highly unlikely that these 5 are clogged and this one's flowing what it's supposed to. But anyway, this is the first time I've turned this machine on, so let's see if that's better. I don't know if that's better or worse. It's definitely the same result. So yeah, I was thinking that pump or that tank wasn't quite big enough, but it looks fine. It's amazing how much this sounds like an idling engine. I was once touring a Pure Power factory, and they had 7.3 diesel fuel injectors running on a test stand. I swear to you, it sounded like a 7.3 Ford Power Stroke, or a row of them just clattering away. Just such a distinctive sound, and terrible. But most of the noise you hear from those 7.3s is, you know, well, there's a lot of combustion knocking happening, but most of it is a stupid injector. Alright, that's enough of that fun stuff. I'm going to do some more scientific tests that I'll run at the same parameters, and I'll write down, I'll figure out what milliseconds to run the test at for what size injector and what pressure, and then kind of quantify them so I can put them on a graph and see what they all look like relative to each other. And then we'll run it through the cleaning cycle with some simple green or maybe some actual injector cleaner, and then we'll do it again. Okay, so I did some messing around with this thing, trying to figure out how to make it work, and this is what I got. This is test number 9, which is 3 millisecond pulse. I ran it for 400 seconds, and this is what I got. Cylinder or injector number 1 hit 82, and then 6, this. So, and then I ran it again at 500. I didn't write it here, but it was for 500 seconds because I wanted, the higher I fill those graduated cylinders up, the more accurate it's going to be. So I did it again, and this is like, I don't know, 5-minute test or something like that. Well, 500 seconds, so about that. And then I ran it again, and I got really good repeatability. So then I put these 4 injectors back in, took these out, these 4 out, put these back in. So 1 and 6 should be consistent because it's the same test, right? So, and then I ran that, and then I noticed that it was slightly less, and it was because the fuel pressure had dropped like a couple PSI. So I bumped that back up, and then it came to the same number again. So this is what I got as each injector. This was 104 cc's, this 102, 115. That 3 was high when we did the first test. So 101, 105. So pretty inconsistent. So this is the average. And I also ran a standard deviation on it. Standard deviation is 3.98, which not a good number. So I just went to this standard deviation calculator and poked in all my numbers, and that's what it came out. So mean is that, and standard deviation is that. So what I did next is I cleaned the injectors. So I ran them through the ultrasonic cleaner, 5 at a time, and then I reran the test, and it changed a little bit. This went from 104 to 106. This one went from 102 to 104, and that one stayed at 115. That one went from 101 to 103. So a couple of them gained a couple percent here and there. And then this is the average and the standard deviation. So it definitely did something, right? It made the standard deviation go down, and the percentage go down, and the average go up. So, and I'm using simple green and water, so there's probably better solutions out there than that, but that's what I used. Okay, so what I did next was I whipped up a little spreadsheet here. So actually this is 276, I believe. So I made this kind of a quickie calculator. All the green are what you input. And I just wanted to explain to you how injectors work, and so I can use this thing to kind of calibrate the size of them. So what I did was this is the size injector and cc's per minute. I converted that to pounds per hour. This is the pressure that it runs at in bar. I converted that to PSI. And then this is the injection frequency. Now I don't know, or when I wrote this spreadsheet, I didn't know the injection frequency. Let me explain why that matters, right? If you make this thing bigger, it makes the pulse width longer, and then your flow goes up, right? So if you don't know, because every at 6,000 RPM, there's a combustion cycle every 50 hertz, or every 20 milliseconds. So, but at 2,000 RPM, that's every 60 milliseconds. So 3 times as much fluid goes through there. And I didn't know when I wrote this program what speed medium speed was, and what speed high speed was, and what speed idle was. So actually what I did is I hooked my oscilloscope up to the tester, and I made it trigger on this injection time, and then this is 25 milliseconds, so 25, 50, 75, 100, 125, 150, 170 milliseconds. Okay, so now I know it's 170 milliseconds. I can change this number, and it's about 700 RPM. So that's what they're using as an idle speed. And I did this for not only for idle speed, but I did it for medium speed and high speed. And it turns out medium speed is 2,000 RPM and high speed is 6,000 RPM, which is helpful. So now I can calculate what the flow numbers are. And then if I put my runtime in here, 500 seconds is what I ran that test at. It comes out to the same flow, sort of. So this is what I got for an average. Now, let me explain what I did. It had a 3 millisecond pulse width, and then this rise time here, I put 0.2 milliseconds. And the reason I did that was because if that's 0, this is a bigger number, right? This is ideal flow, and then since things can't happen instantly, what happens when you open up injector is this looks like it's going straight up, but it's really not. Right? If we make this bigger, we make this 1 millisecond. Now you can tell that that is on an angle. And if you make it, 1.5 milliseconds open time, you can see that the area under this curve is smaller the longer it takes to open. So you have to know this. When you get a set of injectors, when you get a set of float injectors, certainly they should give you the opening time. Different operating software uses different parameter name, but it's essentially the same thing. So, so adding this 0.2 in there makes it very close to what I got for the average flow. So now that I know what this is, now I can go through and go, okay, well, I have a 900 cc injector and it's running at 3 bar. I can only run that because I only have 100 cc cups. I can only run that for, say, 200 seconds. Nope, can't run it for that long. 150 seconds. There. So now I should be within the range. So I can just put whatever cc injector I have, set the pressure at the pressure that the injector is rated at, or the injector pressure that I'm running it at, and then I can run this test. I can run 2,000, I can run 6,000, and it'll correct for each one of those because that's what the spreadsheet's doing for me. And then over here I have my idle test. Actually, this should be more like 700, 2,000, and 6,000. So quickie little spreadsheet, but I also wanted to show one other useful piece of information. This V10 spins kind of fast, right? So when I change that injection frequency, now this is how much time I have, right? I only have 14.5 milliseconds between combustion cycles. So if I want to put a pulse width that's 20, well, yeah, good luck with that. So I can maybe go to a 12 millisecond pulse, and then this shows how much time that's on, and that actually is right here, 82%. And you don't really want to run an injector at 100%, right? It's not designed for that. Somewhere, depending on what you're doing with the car, 85% or less is usually okay. If there's small spurts of going to 90%, that's probably okay. But typically your automotive production vehicles are running in the 85 to 90% maximum duty cycle range. And the reason they do that is because the smaller injector you can run, the better you're going to get atomization and emissions and control. The faster it opens as well. So if you're on huge injectors, it's more difficult to get to pass emissions. So But I just wanted to explain that you can't go to 3,000 RPM and have a 15 millisecond pulse width. It just doesn't work. You just don't have enough time in the map. So this is kind of nice that as a picture of what happens. And then this rise time is not super critical at 8,250 RPM, right? It's kind of insignificant. But at idle, like at 700 RPM, that's a big percentage of the amount of fuel going in there. So, because you might be idling it, 2 milliseconds, 3 milliseconds, depending on the size of your injector. It's pretty small. So this makes a lot bigger difference in that scenario. Okay, so now that I put this thing through its paces, I wanted to make a list of things that I want to fix. So here's my list. I'll put that on the screen better, but basically I can't really fix this, but you can't change the pulse width unless it's running. So you can run a test for whatever, 100 seconds or whatever, but you can't change the pulse width unless the test is already running, which is kind of stupid, right? So you're kind of limited. If you want to run a time test, you're limited to the 3 milliseconds that it defaults to, which I can work around that. The big one is the fuel pressure has no regulator. And let me demonstrate that right here. So I'm going to put this on a acceleration test, which is test number 5. These buttons are backwards too. The top one should be up and the bottom one should be down. That's stupid. But whatever. I can work around that one too. So there's an acceleration test. So look at the fuel pressure. Dropping like a stone. So that's no good. You can't run a test with an acceleration. I mean, you can compare, but you don't know how much fluid's going through there. So that's not great. So if you're running a standard test, you can just change this and it'll change the pressure at that. But it's like in kind of discrete steps. So I'm going to add a fuel pressure regulator to this fuel rail and then drill a hole and make it a return into that tank. So then I can have a little thumb screw, and I can adjust it. The other thing that I'm going to add is trying to read these very accurately is pretty difficult. So I think what I'm going to do is take these off, leave this here, just put some standoffs in here, and then put a graduated cylinder under each of them. And then what I can do is put this, all this is the same, and just weigh a graduated cylinder and stick it in there, and then weigh it afterwards, before and afterwards, and do the gravimetric measurement. So that will be much more accurate and not subject to parallax and trying to read this and whatever. These adapters kind of suck too after playing with it a little bit. The injectors don't, like the sealing, the O-ring seal doesn't go into this thing, and it only goes into this thing like a tiny bit. So like that's the interface to the O-ring, and the O-ring doesn't go all the way in there. So what you end up with is you can't just stick the injector into that and it'll stay like it does in a fuel rail. So I'll probably take these things off and put them on my lathe and machine those out so it goes all the way in for a 14 millimeter dealio. So that's my adapters suck. I'm not sure how this is supposed to be, but it works much better being right-handed. So I can just grab a hold of the connector on the back and grab a hold of the front with my left hand. I'm holding the camera now, so I can't. And then this should have like a little holster back here, so they stay in order. So I'm going to make a little doodad that just has a little, you know, I don't know, 3/4 inch hole in it. Boop. And then when I'm done with one, I just stick it there and I can still read one and then just pop it off like that. So it should have that already, but it doesn't. And then the last thing is these lights suck on the outside. I think they have this LED light in here for the 4 injector version, and then they just made a 6 and used the same light. So these outside ones really don't help at all. It makes it look completely different. So that's not awesome. But if I do a gravimetric, that doesn't matter anyway. So, but overall, oh yeah, and one other thing. Since this tank doesn't have a heater for the ultrasonic, I just got one of these, like $6. So I'll just jam that in there and then I'll have heat. And so this will be the end of this video, but I will make another video of all this stuff that maybe I'll figure out a workaround for how to change the pulse width stuff. I mean, there is a workaround that you could like set it to a different speed and wait for it to count down to an even minute and then plug the injectors in and resume. Like you could totally do that, but that's a workaround. It's not great. The regulator I'll fix, the gravimetric I'll fix, the adapters I'll fix, the holder I'll fix, and I don't know what to do about the light. Maybe I don't need it anymore if I do gravimetric. But anyway, overall, I think this is a pretty good product. It's, you know, super inexpensive. But of course, I can't leave anything alone, and I got to make it better. So thanks for watching. If you like this content and want more, subscribe, like, and share.